So welcome back to the part 3 of our email archive database full text searching. So we're in pretty good shape. We've got our database all loaded. We've got a nice little gist index, and we're able to do TS query where clauses. Now I want to explore a little bit more of the kinds of things you can do with TS queries. So far we've been doing single word queries like to TS query English Monday, but now I want to add some things. And so it turns out that this little TS query language is actually a query language, and interestingly you can make syntax errors in it. So personal and learning, when you're querying for personal and learning, you are going to find that says I need both of those words. It's sort of a standard and operation. So that says personal and learning have to show up in those rows. So then we can select the words but in order, and this use the operator that is the less than dash greater than. That says personal and learning, but personal has to come before learning, and so that's ordering. So that basically will give us a different set of rows. I don't quite know why there's no personal followed by learning, but it's not there. We found no rows. Let's see if it goes the other way. Learning followed by personal. And there we go. We have one that has learning followed by personal. So learning followed by personal is the way that I read those. You can add a not. I want learning and not personal. Not personal. Exclamation point is not. Exclamation personal ampersand learning means not personal and learning. See what we get for that. Yeah, we got a whole bunch of learning without the word personal. So very few people are talking about personal learning or learning and personal in the same sentence. So that's one. So the 2TS query, like I said, is a language. And I'm going to make a syntax error when I say parenthesis personal learning. And that's because inside this string, it's actually a query language of its own. And so this one is going to give me a syntax error. Oops, need a semicolon there. So it says syntax error in TS query, and it didn't like the syntax of it because I used a special character in there and in a way that it didn't like. And so if you're taking stuff from the user, you'll use this plain to TS query. And so it's like, well, whatever, I'm just going to throw away things I don't understand rather than blow up. So I look at the personal learning with a parenthesis, and it can work, right? And this is a syntax error from to TS query, but it's not a syntax in plain. It just throws stuff away. We can look at phrase to TS query. I followed by think. First, we'll do it without phrase to TS query. That's what we see. That is I followed by TS query. And the phrase one is just kind of like a phrase. And so it's I think is a phrase, which is I followed by think. It really is a transformation from this I space think to I followed by think. And again, you could think of this as something where you're letting the user type something, but you don't want them to have to know how to type all these fancy things that 2TS query. And if you have Postgres greater than 11, you can take a look at this is a syntax that kind of came, this minus personal learning is a syntax that kind of came out of Google. That is a way to say not personal and learning. It's the same as this. And so this is web search to TS query. A lot of people are going to end up writing kind of little grammar transformers that would take these Google style things and then convert them. So that works. English minus personal says not personal plus learning anywhere in it. And then the last thing I want to do is I want to show you something about text ranking. So text ranking it's important to know that text ranking is not really participating in the where clause. All of our optimization and inverted indexes and all the stemming is to make the where clause go faster, to pick the documents you're going to see. Once the where clause is thrown away, most of the documents, which is its goal, then the documents are retrieved, and the rank, right? The rank is a computation based on the retrieved documents, and then you can order by. I can order by TS rank descending, right, and give me the most highest rank. And the TS rank takes a TS vector and a TS query. Cleverly, you probably would want them to be the same, but it doesn't have to be the same as the where clause. But in this case, so what it's saying is, like, we did pick it, and the double at said that personal and learning were in this document, but then we're saying how good were they? Were they closer, etc., etc., etc. And so there's a couple of different ranking functions, and you can read up on those. But the TS rank is just a calculation on the retrieved documents. So let's take a look at this. And we're going to print the rank out. So now this is this rank, right? And it's ordered in descending order. So this one here is the seemingly most relevant about personal learning. And I think if we looked at that one, we would probably agree with it. And some of these have less and less relevance as they go on. So that's really cool. And then there are more than one ranking algorithms. There's this TS rank and then TS rank CD. And you can read up on those in the Postgres documentation. They both simply are computations on the retrieved record set, and they just do a different computation. I'm not sure. In this case, it even threw out some things that were in or out, and that's because it does a different calculation. And so there's a whole bunch of research on how to do ranking, etc., etc., etc. And so that's where I'm going to stop. I've got some stuff where you can use regular expressions and make indexes based on regular expressions, and I'll leave that for another time, and you can take a look at that. That's sitting here in this 06-python.sql. Okay? Hope you found all these demonstrations useful. Cheers.